Now we're going to move on to a new section, finding the arc length. So the arc length is, let's say this here is A, and this here is B, and this is your equation here. The arc length is really the length from here to here. So this here is your arc length. So we've seen in the past that to work out the volume of a sphere, we would start with our equation, and then we would rotate it 360, and then sum up all the disks. And by us summing up all the disks, it will eventually give us the volume of a sphere. So this is us summing up all the disks. By us summing up all the disks, it will eventually lead us to the volume of the sphere. And we've done this many times, so you should be fluent with this by now. Okay, so the next question is, how do you work out the surface area of a sphere? You see, to work out the surface area of a sphere, let's say this here is A and this here is B. To work out the surface area of a sphere, we would need to somehow develop a way of finding out the arc length of an equation. So once you've got this arc length here, you can then rotate it 360. Rotate it 360, and the area. When you rotate it 360, it will sweep out an area. So when you rotate it 360, it will sweep out an area, and this area, it will eventually lead to the surface area of a sphere. So to work out this surface area of a sphere, you would somehow develop a way. You would somehow develop a way of finding out this arc length here. And then once you've got this length here, you can rotate it 360, and then that will eventually sweep out the whole surface area of a sphere. So our next step is to somehow develop a way of finding out the arc length of any function. So let's say we've got a function here. We would need to develop a way of finding out this length here. Okay. So I'm just going to brush through the idea behind it, and then in the next video I will take it step by step. So let's say you've got any function here. To work out the arc length, to work out this length here, we're going to split it up into n number of strips. Let's just zoom into this particular strip here, any strip. Zoom into that, and it will look something like this. So the idea here is to somehow use Pythagoras to work out this length here, and then eventually, so we're going to somehow use Pythagoras to work out this length here, and then this length here is an approximation for our actual length. You see, this here is our actual length. This here is our actual arc length. But then we're going to use Pythagoras. We're going to sum up all these lengths here. But then eventually, so this here is our delta x. Eventually, we're going to make delta x tend towards 0, and then eventually this length here will become this length here. Okay, so the idea here, the idea here is to work out this actual length here. We're going to split up into n number of strips. So this length here is your delta x here, and then we're going to use Pythagoras to give us all these straight lines here. And the idea here is that the arc length will approximately be us summing up all the diagonal lines here. It would be us summing up all the diagonal lines, and then we will then the arc length, the true arc length, equals this when we take the limit as n tends to 0. Remember, n is the number of strips. So when you make n tends to hang on, bear with me, as n tends to infinity, okay, as the number of strips tends to infinity, delta x will tend towards 0. Okay, so our aim here is to increase the number of strips. So as we increase the number of strips, this delta x here tends to 0, and then so the actual arc length is approximately us summing up all the diagonal lengths, and then we would then increase the number of strips to infinity. So from here, we would then use well, we've seen this in the past. We would use these three components here to allow us to jump to the integral. And I'm just brushing through the concept. In the next video, I will take it step by step. But roughly speaking, we're gonna increase the number of strips. We're gonna increase the number of strips, and then eventually it will become an integral here. I will explain more in detail in the next video.